In this question it is given that the masses and radii of Earth and Moon are m1 r1 and m2 r2 respectively. Their centers are at a distance of d apart. The minimum speed with which a particle of mass m should be projected from a point midway between the two centers so as to escape to infinities. So over here in this question it is given that the masses of and radii of Earth and Moon are m1 r1 and m2 r2 respectively. So we are considering that there is a sphere of mass m1 or Earth of mass m1 and its radius is given as nothing but r1. And another one is nothing but a moon, and the radius of mass as well as radius of moon is also given. This is given as nothing but m2 and its radius is given as nothing but r2. Their centers are at a distance d apart. So their centers are separated by a distance which is equal to nothing but d apart. The minimum speed with which a particle of mass m should be projected from the point midway between the two centers so as to escape to infinities. Our aim is to find out with what velocity we need to project an object from their center. Let's say we are projecting with the velocity v so that it will escape to infinity. So this distance we can take it as nothing but d by 2, and this distance we can take it as d by 2. If there is any question related to escape velocity, so the concept is the net energy or total energy should be equal to 0. So we can find out what about the value of total energy of the system. So let's say if you are projecting an object of mass m from here, so its total energy means sum of its kinetic energy plus potential energy. So we can write its total energy is equal to sum of its kinetic energy plus potential energy. Its kinetic energy is half into m into v square plus potential energy is potential energy due to m1 and m, we can take it as g into m1 into m divided by distance between them is nothing but d divided by 2. Like that we can write the value of potential energy between m2 and m, that is g m2 into m divided by distance between them is d by 2. So this value should be equal to 0. Then we can say that the satellite will be able to, or that object will be able to escape. So condition should be like this: the total energy should be equal to 0. So we can find out what about the value of velocity required for this. That means half into m into v square should be equal to g into m divided by d by 2. We can take it as common. So remaining thing is going to be m1 plus m2. So we can cancel this m and this m. So the value of this v square can be written as, this is 2 into 2, that is 4g divided by d into m1 plus m2. Or you can write the value of velocity should be equal to under root of this value, that is 4g into m1 plus m2 divided by d. Or you can write this is equal to 2 into g into, or if you are taking this 4 outside, it is 2 into under root of g into m1 plus m2 divided by d. This will be the value of velocity with which it should be projected. So for any question related to escape velocity, the concept will remain same. The value of net energy or total energy should be equal to 0.